doctoral student and junior faculty consortium. Today's topic is on issues with longitudinal and process studies research designs. Is a topic that if many of you, if not currently, will sooner or later run into in some of your research projects. So what we did again for this session is we put together an exciting panel of experts on various aspects of longitudinal research designs. And we have 3 panelists accordingly focusing on one specific topic respectively. We will start today's session with Philipp Tuertscher from the Vrije University of Amsterdam, and he will talk about qualitative approaches to process research and use his work on studying innovation as an example to illustrate these qualitative approaches. We'll then have as the next panelist Christian Dormann from the University of Mainz, who will speak on continuous time meta-analysis, in other words, how to do meta-analysis that takes a longitudinal perspective. And finally, we will have Trevis Certo from Arizona State University, who will present on between versus within unit effects on longitudinal data. And so I think as a whole then, this will be a very useful and informative session to shed light on a number of different aspects of longitudinal research design. As we're starting the session, I would also particularly like to thank, as usual, all 3 panelists and also Christian Dormann and Philipp Tuertscher, who are located in Europe, for taking their evening, for being with us. And then, of course, Trevis being in Arizona for taking his morning for being with us. Without much further ado, I would like to turn over the floor to Philipp, to our first panelist, and talk to us about qualitative approaches to process research. Thanks, Philipp.
Okay, thank you, Thomas, very much for this introduction. I need to say I'm pretty excited about this, and I need to confess that this is the first time for me doing such a virtual PW. And actually, I should have done a thing like this before, because my home division is the Technology Innovation Management Division, and we should walk the talk and use IT and fancy technologies for doing such kind of PTWs, but we're still doing it the good old style. So good to learn from the methods division about doing this. I'm just trying to get my PowerPoint up here in presentation mode. Yes, so as Thomas mentioned already, I'm from the Vrije Universiteit in Amsterdam. And I am process research. So we're the Kind Center for Digital Innovation, and we're studying phenomena mostly related to innovation. We're all studying very much process research, practice research, and mostly with qualitative approaches or mixed methods approaches. But also in our group, we have been making a lot of efforts also to try to develop more methods, also how to study processes such as innovation. And that is also something that I would like to talk about today, less about my own empirical work, but a little bit about some work that I've been doing with my colleague Hans Behrens at Vrije Universiteit and my colleague Raghu Garud at Penn State University. And also we have a book chapter in a book on qualitative methods that Sanjay Jain has co-edited. So he's also the one who invited me to the session here today. And basically, the things that I'm going to talk about in the next 10 minutes will mostly borrow from this chapter that we've written here. And what I wanted to do today is very briefly to clarify a little bit the key terminologies, what it is when I'm talking about qualitative approaches of process research. And first of all, I would like to clarify what is process by distinguishing it from the variance approach. So as qualitative research is very influential, there's Moore's work on process research. And he starts basically by contrasting a process approach against the variance approach. So the variance approach is basically you have an independent variable, which is the precursor. It's a necessary and sufficient condition for an outcome by. The process approach is very different. So you are not looking at efficient causation here. You're not looking at a certain set of independent variables affecting a dependent variable, but you're looking at a series of occurrences in a sequence over time that explain how a phenomenon unfolds, how a phenomenon comes about. And the very important difference between those two concepts is that the role of temporality, the role of sequence matters pretty much. And you may have a lot of different ingredients into a process, and depending on when you add them, in what combination you add them, in which sequence you add them, you will get different types of processes and you will get different kinds of outcomes. And so that's also something that Anne Langley has tried to visualize in this figure that I'm showing here on the slide. Now, what's very confusing, there's a lot of researchers in management that are using variance models, and they call them process models. So this is an example. I just quickly looked in Google Scholar for process models, and this is a 2008 AMR paper that it's clearly showing there's nothing about sequence. There's no temporality. There's nothing about temporal patterns. This is really a normal variance model. But people can look at variables in a process, in something that empirically you could conceptualize as a process when theorizing, but they're measuring it as time agnostic variables. And so this is something that I just wanted to quickly point out. You need to be careful when you're using a process ontology that you're also using a process epistemology and vice versa. Now, there's different flavors of process models, the way we're looking at them. And one of them is process as observed, typically as observed by the researchers. And those are typically studies that are looking at sequence of events representing changes in entities, changes in things. And there's different things. You can have things at different levels of analysis, and they interact with one another, and then they generate events, they generate changes that can be observed empirically in the field. There's a different flavor of process, and whereas the first one is rooted in substantive metaphysics, the other one is process metaphysics. And this is process, we call it process as experienced. And is experienced not by the researcher, which is a big difference to the first one, it's experienced by the actors in the field. And here, things, of course, also exist, objects also exist, but they're conceptualized as a reification of the process. So the things are subordinate, and what matters and what we are, as researchers, are interested most is the process of change. So what we're doing with this process as experience, we're interested in how actors experience change as they do things, or as things happen to them. So it is this experience that's very important. And then what you also can have hybrid approaches that are something in between, or combinations of the both process as observed and process as experienced. Now, what should a process model do? A process model should identify the outcome of interest. So what is the process about, and what is the process leading to? And that's very, very important, because the outcome that we defined as important, that is determining the process that we're going to find. If we are either looking for events, for important events, or also if we're doing observation studies, or if we're talking to people about their experiences, their process experience. The other thing that a process model should do is it should account for the relevant initial structures and conditions with which the process starts to unfold. And then it should describe the events, and then depending on what flavor it is, either the cognition and actions of actors involved, and also focus on the relations between those different elements of the phenomenon. Also, what's very important is a process model should be something that is, specific enough that it's disconfirmable. Also, we're talking about qualitative process models here, so I also want to quickly clarify what I'm talking about when I say qualitative. So it is not the distinction between inductive or deductive. So when I say qualitative, that's orthogonal to this, because you could do inductive research in a quantitative approach if you're doing data mining on process. That's what people who are doing sequence analysis, for example, could do. But what we mean by qualitative is basically that the research is appreciative of the richness of the phenomenon by looking pretty much at the context. And the context, on the one hand, is relational, so that qualitative approach can take into consideration all the various bits and pieces that may play out on various levels of analysis that then make up these activities or the elements of change in the process. And also the temporal sequences, the patterns, the temporal experiences of the people involved. So these are the two context elements that the qualitative approach takes into account. And as with all qualitative research, the more we endogenize in our theorizing the relationality and the temporality, the more we move away from ex ante predetermined categorize, and it goes more into the realm of meaning and interpretation of the phenomenon as observed and as experienced. Now, I've briefly mentioned this book chapter, and in this book chapter, we were looking at process inquiry approaches to innovation studies. Innovation, that is my empirical home. What we've done here is a very extensive analysis of examples of templates of different flavors of process research. Also, we are comparing it to the variance approach that's also looking at the process of innovation, but is not using a process methodology. And what we've done is we've compared the objectives of the researchers, what those different styles of research on innovation as a process, what they're trying to accomplish, and also to look at the various methods that they're using. And this is just the tip of the iceberg of this table. So I showed the reference for that article, and I don't think it's available open access. So in case you want to use it as a resource, also feel free to send me an email, and I'd be happy to share the PDF of that chapter. But we have a very, very detailed table showing examples of process studies on innovation as a process that is looking at the objectives of the research, the methods that they're using, going into detail into the research design, the approaches for data collection, the types of data they've been using, the types of analysis, and also what's very important for process research, which is the most tricky part for me in process research, the reporting of the findings. Because process research is about a non-linear phenomenon. It's very often also multi-dimensional, and that's something very difficult to capture into a linear format like a normal paper. And just to give you an example, so this is one form of a representation of process as observed, which is showing sequences of events playing out on different levels, and also the relationality, how the different events are connected and how one event is triggering a subsequent event. And so this is one way of visualizing process as observed. And but it's a whole different story if it's about reporting on a study that is about process as observed, where it's very much about use of observation, ethnographic methods, where it's about how people experienced the messiness of a process. And this is here an example of a paper by Raghu Garud on innovation as experience process, which is showing example of documents, pictures from the fieldwork, the documents showing the messiness of the process of coming to a report of the innovation project. So this is a very, very different way of showing the processual complexities involved. So lastly, I want to speak quickly about how to decide which approach to use. So is it more useful to use a variance approach? Is it more useful to use a process as observed? Is it more useful to focus on a process as experienced by the actors involved? Well, that depends pretty much on what the researcher wants to know. But it's very important also to be reflexive when making these choices, and also make sure to avoid a mismatch between ontology and epistemology. And Thompson has written about two possible problems, two possible fallacies that we are prone to tap into as researchers. So one is the fallacy of reification. So that is that researchers subscribe to a process ontology, but they're using methods that are rooted in an entity or substance epistemology. So an example of that would be that we conceptualize the innovation process as a nonlinear process, as a messy process, and then rather than focusing at the various events and looking at the temporal sequence, how this process unfolds, a researcher would use a survey that is using the bumpiness of the process as an item in that survey. So that is something that would be definitely a mismatch of the ontology and epistemology. The opposite could be the fallacy of processification. So that we are trying to explain, well, that we have an entity ontology, that we're interested in things, but we're using a process theory, we're using process methods, and that, again, that would be a disadvantage. Now, it's very important to also have this in mind when we're thinking about the audience. So one challenge with process research has been, with qualitative process research for some time, has been the review processes, that we end up with reviewers who are using quality criteria for judging the research that are rooted in a substance epistemology. And it's very tempting then for process researchers to also switch over to substance methods But the problem with that is we are doing violence actually then to the process ontology. So the alternative is to push back and to be very, very clear about the quality criteria that we might use for a process approach. And it's the importance of narratives, for example, the importance of verisimilitude as alternative qualities, as alternative ways of making sense of empirical data as compared to the traditional reliability or validity measures that people who are experienced with quantitative research would use. Well, so I hope it didn't go too much over time. Let me stop the slides here again. And Thomas?
No, this was great. So it's now a call to the audience to please use the Zoom group chat function to send in any questions they have for Philipp about qualitative approaches to process research. We have about 10 minutes here to answer questions, so please feel free to bring in your questions. And while we are waiting here for questions to come in, Philipp, perhaps one question about your presentation in your chapter and in your work. Do you differentiate also the problematics of reporting of findings between the approaches to studying processes observed versus experienced from a qualitative perspective? Is that part of your work as well?
Can you say again? Because I had some audio issues.
The different approaches to reporting findings, depending on researchers' focus on studying process as observed versus as experienced. Is that something that you're working on as well?
On the differences, or if I do both versions in my own research? So
my question really was on the differences because you talked about the challenges with reporting findings.
Yeah. And
so my question was broadly about the different ways of reporting findings.
Yeah.
Different focus.
So we do have we have like a 4-page table in that chapter, and there is examples, very good examples, and Langley, for example, has very nice paper also about different templates for doing process research. Now, specifically for innovation studies, we looked at different papers, and as examples for process of observed, that would be from the Minnesota Innovation Research Project of Andy Van de Ven and colleagues, for example. That would be descriptions of chronologies of events. And this could be within and across different tracks of things that are happening. So it could be on an institutional level, for example. It could be within an organization. It could also be at different it could also be different entities in an ecosystem where different events are unfolding. And so there could be Petri net diagrams that are also showing how events splinter up, basically. It could also show how a process diverges and converges over time. But these are all changes, critical events that can be measured on a time scale. You could have frequency distributions of the events. So you can very easily visualize those kind of events. Right. Now, it's a little bit more difficult with process.
Excuse me, please. Actually, we have some questions now from our audience. So if you could, I would like to use the time to get to those. So the first question here is, whether is it possible to use case study methodology for process research, and maybe from a weak process approach, and references here made to Andrew Van de Ven's work?
Yeah, precisely. So, I mean, people are also talking about the weak process is process as observed, and then a strong process that would be closer to the process as experienced. by Tia. Now, the question was, is it possible to use case study approaches for process? Yes, sure. Why not? So you can use, well, a case study is not a specific method of analysis. So you could use a case study using a variance approach. You could do a case study using a longitudinal and then more likely a process approach. Yes, certainly that's possible.
Okay. Another question here was about your last slide where you mentioned to be careful not to cave into reviewers concerns related to substance. And if you could elaborate here on how you might develop a response to reviewers' concerns.
Yeah. Well, basically, I think a way of responding to this is now to refer to the emerging gold standard for process research. So we've had a lot of PDWs in the there's been this very, very nice symposium also on theory methods packages at the Academy, I think 3 years ago, where we had a comparison of the Joya method, which is more like a variance approach or suitable for a variance approach, versus Langley's with temporal bracketing. Also Eisenhardt, who in much of her work is talking about processes, but is actually looking at comparative patterns. And so it's not really compatible with a process philosophy. So I think there is increasingly, there's a lot of assets in terms of good examples that can be used as a model, but also very good editorials. And I think it is very important to refer to those templates in the method sections already, that you explain, that you model the study after a certain process approach. The other thing is, if reviewers try to measure you using not a suitable standard, try not to adopt it and try not to let yourself put you into their framework. Try to explain and also have a dialogue with the reviewers, educating them about this different approach that you're using, and probably also the editor will understand and will help you in this process.
Okay, we can take one more question here, and here it is, just in time. What is the difference between grounded theory approach and phenomenological approach in the context of process research?
This is a difficult one for me to explain or to address. I don't have a good answer to that.
Okay, that's fair enough. If something comes to your mind, we have the chat function going on. You could reach out to this individual asking the question. Other than that, I would like to ask the audience to use the chat function here to shout out to Philipp, to thank him very much for a very informative presentation. And we will move on now to the second presenter. And then if we have some time at the end, we can still also circle back to any questions that may come up with respect to Philipp's presentation. So
thank you very much.
Thank you very much. And I would like to turn over the floor now to Christian Dormann here, and who will speak to us about continuous time meta-analysis. Christian, the floor is all yours.
Thank you very much, Thomas, and thank you very much for inviting me to participate here in this session, which I really, really love. And actually, it's the last thing I will do before I will go on vacation tomorrow morning. What I will do, is, I have to move here a bit. What I will do is on my first slide, I will go mountain biking 1,500 meters in 3 hours and then have 6 hours long tail tomorrow afternoon. However, the slope is there for another reason, and please remember that slope throughout the presentation, because I will come back to it. The slides I've selected, they are also part of a 60-minute tutorial to a continuous time meter analysis, which you can find at www.applied-psychology or applied-psychology.com. There's also some literature and some further material. So basically, I mean, most of you are familiar with meter analysis. This is either on effect sizes in experiments or, for example, on correlations. Trevis also had a meter analysis on correlations on equity and company performance. And usually what a meter analysis does is just somehow aggregating, averaging, synthesizing the correlations, weighting them by sample size or some other thing, and then come up with a single estimate of best estimate what the correlation would be, could be expected to be in the population. And the problem is that in longitudinal studies, things get a little bit more complicated, but the solutions are available, and I will talk a bit about this today. And so an easy thought could be, for example, if you think about a longitudinal study where variables are measured on more than a single occasion, that you, for example, have a job satisfaction measure at time 0 and a job performance measure at time 1, that you simply take the correlation out of the primary studies, collect them, and then do a meter analysis on these lagged correlations. However, there are some pitfalls, shortcomings, and really serious problems that I will outline in a second. More often, researchers are also frequently not too much in just mirror correlations in longitudinal studies, but more in terms of lagged regression coefficients. So, and how far does job satisfaction time 0 predict job performance, for example, at time 1? And at the same time, they control for prior job performance, and they also control for possible so-called reversed effects of job performance on later job satisfaction. And the figure here is simple cross-lagged autoregressive structural equation model that people frequently use in longitudinal research. Basically, what we would have to extract from primary studies are not such regression effects. What is sufficient is simply the correlations among the variables. I will show you briefly. They just input into our program, and what comes out then are the effect sizes. But let me first illustrate the problem a bit. Suppose there is a research or a group of researchers has conducted a study on job satisfaction, job performance, applied such a structural equation model, and came up with these estimates. So a cross-lagged effect of job satisfaction on later job performance of 0.123. The problem is, if suppose these are the true causal effects, that if such a process unfolds over longer periods of time, let's say one lag is here 1 month, then let's suppose the process unfolds across 7 months, then the researcher would come up with these estimates. And obviously, these two cross-lagged effects differ. The cross-lagged effect of earlier job satisfaction and later job performance is larger when the time interval a researcher has chosen for his longitudinal study, in this case, is longer. And obviously, this is not easy to say what is a true effect. What kind of effect, if, for example, more than 2 waves are used in a study, should be entered into a meter analysis. Things get even more complicated. Sometimes in meter analysis, researchers are interested in moderators, that is, contextual circumstances, characteristics of studies that make effects larger or smaller. Suppose there's another researcher, let's call this the red study, and this study came up with the effect of job satisfaction across a 1 month lag on job performance of 0.204. Obviously, this is larger than the same effect using the same time interval in the blue study. Now, suppose further, this study also unfolds, or the process unfolds across several months, then we end up with such an estimate. And now things are really, really confusing. So both studies, the blue study and the red study, when using a 1 month lag, came up with small estimates and a larger estimate, stronger effect in the red study. If both studies had used a 7 month lag instead, both studies would have come up with larger effects. But obviously now in the blue study, the effect is larger than in the red one. So this is all pretty confusing. And in fact, such cross-lagged effects in longitudinal studies depend on the length of the time lag and also on all the other effects shown here on these slides. And the trick with the continuous time meta-analysis that I'm presenting in a second is that this continuous time meta-analysis COTIMA rescales, so to say, the effects that are discovered in the primary studies to an identical time lag. And this can be then aggregated. The rescaled effect, they are called derivatives or derivations. You do not need to know much about it. It's all done by stochastic differential equations, but you actually do not need math knowledge to understand. It's just important, I believe, to understand the general principle. Okay, so what do people have to do if they want to conduct a COTIMA? I suggest to my students to print out a couple of slides with such a figure. For example, student was interested in the job satisfaction, job performance, longitudinal effects, so print out a couple of figures, and then go through the primary studies, typically table 1 in our studies, and then select the correlation. So first of all, the time zero correlation of job satisfaction with job performance, put this to the figure. Then the job satisfaction test-retest correlation, write it down. The lagged effect of job satisfaction on later job performance, which is 0.14. The reversed causal effect, which is 0.20. The stability of job performance, which is 0.69. And the within time correlation, within time 1 correlation of these two is 0.21. This is all what you have to do. And this is what you have to do for each primary study that you could have identified in the literature. Then you have to use R, the computer program R, and this is all explained and even how to install it on the website www.applied-psychology.com. And I zoom in. So what you have to enter for each primary study is the time lag. In this case, I've provided it in months. So delta T1 for study 1 had a 6-month time lag. The sample size in this study was 222. And then you enter the correlation matrix. This is exactly the same numbers that we just have found on in table 1 on the previous slide. And this is a 4 times 4 correlation matrix. And this is what you have to do for each primary study. The example I show here has used 10 studies, but it also works nicely if you just have 3, for example. It could also happen that some primary studies have more than 2 waves, for example, 3, and the time lag between the first and the second is 6 months, and the second and the third is 3 months. Then it is pretty simple to enter these information in the way it is shown on this slide. Obviously, then the correlation matrix is a bit larger and now has 6 rows and 6 columns. And even if it's 4 waves, 5 waves, or so on, it's all done in the same way. So after all the information of the primary study is entered, you simply mark the script and say run, and then a lot of output is produced. It takes a time. You can have a coffee in between. So 15 minutes or so with 10 studies is a reasonable estimate. And then you get a lot of results. I will just focus on 2 results. This is one slide and the next one. So what you see here is for the 10 primary studies on job satisfaction and job performance. First of all, the so-called auto effects or autoregressive effects of job satisfaction. This is on the left side. So the stability, so to say, of job satisfaction, and the stability of job performance on the right side. They are all negative, and this has to do with the continuous time math. I will later show what this actually means. As a heuristic, you can just add 1 to them, and then you have a reasonable test-retest stability. What is of more importance usually are the cross effects of job satisfaction on performance, or on job performance on later job satisfaction. And they are found here. And some of them obviously are negative, which is what probably most researchers would not have expected. Their job satisfaction reduces job performance. However, they are all not significant. In order to become significant, an effect has to be twice as large as its standard error. And this is obviously not the case in neither of these 4 studies. So this is not a meta-analysis. This is just a reanalysis with continuous time modeling of the 10 primary studies. The heart, the core of the CODIMA is found on the next slide. And this is actually technically called a multi-sample homogeneity model, in which all the coefficients are forced to be invariant across primary studies. For those familiar with structural equation models, it's basically a multi-group structural equation model that applied continuous time math. And the most interesting part is this one. This is the effect variable 1 on variable 2. That is the effect of job satisfaction on later job performance aggregated across studies. It's really, really small, and it's not significant. So there is no effect of job satisfaction on later performance. At least it is likely to be very, very small. However, the reverse effect of job performance on later job satisfaction is highly significant, and it is positive. As I said, and then we have the 2 autoregressive effects as well, significant. And I just said these are called derivatives, and they are difficult to interpret. However, they can be back translated into our regular, let's say, regression coefficient world that we are pretty much familiar with. And this is shown on the next slide, and this is done in a graphical way. So for each of these meta-analyzed effects, the program shows how the regular cross-legged effect in discrete time would look like across any time interval you would like to see. In this example, for all the 10 studies, these are the gray lines, we have plotted how the cross-legged effect would have been if they had chosen time intervals between 1 month and, in this case, 57 months. The dashed black line is the aggregated effect, so that's the result of the meta-analysis, and you see that the effect of job satisfaction on later performance could be expected to be always very, very small, irrespective of the time lag that a study has actually realized. It can never expect it to be stronger than, let's say, 0.03 or so. On the other hand, for the effect of job performance, the effects are stronger, a bit more diverse. And you see that here around a time lag of, let's say, 18 months, you can expect to obtain the strongest cross-leg effect of job performance on later job satisfaction, and it could be expected to have an effect size of approximately 0.25 or so. Some studies reveal stronger effects, some also negative effects, but mostly they are positive, and this is the aggregated synthesized effect. So for autoregressive effects, which we are usually not so much interested, the shape of the slopes can be expected to be different. The longer the time lag in a study gets, the smaller usually the autoregressive effect is. But as I said, this is usually not what we are so much interested in. We are usually more interested in the cross-legged effects. And in this case, the mutual analysis has shown is unlikely to be an effect of job satisfaction on later job performance. Happy cows don't give more milk. But on the other hand, performance seems to make people happy, at least satisfied with their job. So this is what probably supervisors would have to do, is enable their co-workers, subordinates, to perform well in order to make them happy. It's, by the way, and now I'm back with my mountain biking tomorrow. This is a general shape of an effect size of cross-lag effect that one could expect across different time lags. It always starts up increasing pretty rapidly, reaches a maximum, and then slowly levels off. And this is obviously the reason why I've shown this slope on the first slide of my presentation. And here it is again. And there are some suggested readings in the end, which is not always on COTIMA, but also on continuous time modeling in general. And yes, there are further features that are available in COTIMA. One is that one can also disentangle within and between effects among primary studies. The topic within and between effects Trevis is going to talk about soon. Yes, but basically, this is it. Thank you very much.
Thank you very much indeed, Christian. As a topic that is quite new to myself, and we are opening here the floor again for questions from the audience. So please, any questions on COTIMA, use your chat function to send them in. Perhaps while we are waiting here for questions to come in, I'll ask a question that came to my mind that probably demonstrates mostly my ignorance about the subject matter. Is when you talked about the cross-lag effects, is there also a way in COTIMA and in the literature that you discussed to parse out the potential effects of different contexts? For example, the link between job satisfaction and job performance in different kinds of professional environments could be different over time, and is there a way to address that?
Yeah, that question does not show any type of ignorance. It's a very good question, because I mean, this is basically what most meta-analysis do these days, is not just aggregating a single effect size and say on average the correlation is 0.20 or the cross-lag effect is 0.25 or whatever, but also trying to figure out in which kinds of contexts or circumstances effects can be expected to be larger or smaller. And this pertains to the question of moderators. The script as it is now set up and available on the website does not include this possibility, because this is exactly the script that we delivered with a recently published paper in Organizational Research Methods. But in fact, the meta-analysis that we have in the pipeline now for publication, which is on stress and burnout and all this stuff, yes, we have included these features as well, because I mean, this advances our understanding of the processes much more than just having an average effect size. Yeah. Under which circumstances does it help? Does it not help? Do people benefit, etc., etc. Yes, and this is possible too in terms of a categorical moderator or in terms of a continuous moderator. That can be done now. Yeah.
That's great. Very interesting. We do have some questions now from our audience. So actually, the first question is, I think you already touched on that, the presence of moderators. How the analysis would change in the presence of moderators. Is there anything you?
Yeah, I think it would be pretty easy. I mean, it is not yet documented, but if somebody's interested, I'm happy to just send it via email. In addition to providing the information, how the time next the sample size and the correlation matrix, there is simply another object that you have to enter in R that is called then moderator 1, moderator 2, etc., etc. And there you give numbers. For example, if it's a mainly female sample, mainly male sample? Is it a US sample or is it a European sample? 2 categories, 3 categories, all this works. And finally, there is in the output a significance test of the effects vary across the different categories, the different moderators.
Great.
Yeah.
There was one question by a person here, whether this can be replicated in Stata, and some way to read up on the underlying math.
So actually, when I read my first paper on continuous time modeling 5 years ago, I didn't know anything about R, and I was reluctant to learn R and preferred to have it done in other statistical software packages. But unfortunately, there are 2 mathematical functions involved that are not available, as far as I know, in Stata, and they're not available in SPSS, and not yet available in M+, although some I'm not quite sure whether it's true or not that they will implement it in the near future, but at a certain point, I'm sure they will.
Very good, thank you. Here we have one user who asks about whether it is possible to do this analysis with a changing workforce, as long as it's the same workplace and some responses are matched.
Yes, certainly it is, and it might be a very interesting question then again with the moderator, for example, how much of the workforce has changed. That could be a continuous variable that could be used to explain whether effects are larger or smaller, for example. Yes, could be done. What we have kicked off the program because it was all too complicated and we struggled with the reviewer was also the possibility to have correlation matrices that are not real full correlation matrix. For example, in some studies, job performance at time 1 was missing. This is also possible, but yes, it is. So I would usually then recommend doing a moderator analysis and see whether in studies where the workforce changed, the effects are different to those where the workforce remained the same.
Great. Here, a question on whether there's a way to correct for unreliability in R. Method.
Yeah, was also included. We also kicked it off, but we do it back into it. I mean, basically, everybody could do it by him or herself, just using the alphas and then use a corrected correlation matrix as an input. But we will automate the process so that you could simply enter the alphas and the correction is done automatically. Yeah.
So, asking a question while there is a question coming, it sounds as though as you're developing this, you're working to find the proper measure of parsimony versus complexity in the COTIMA, what to include and what not to include.
Sometimes I really think our brains are hardwired in a wrong way, because several other meta-analyses we have in the pipeline, it is in several instances it is just that the reverse of what would expect by, I would say, naive or common theory. The opposite findings emerge. I mean, the discussion on the job satisfaction, performance relation is rather old. We had a lot of cross-sectional meta-analysis. They were not always correctly cited. A lot of authors have just read the abstract and quoted from the abstracts. In fact, the cross-sectional correlation is substantial. I would say it's somehow in the 0.30s. But our findings suggest that, I mean, this was just a replication of a meta-analysis by Riquetta published 10 years ago in Journal of Applied Psychology, and basically he came up with pretty much the same findings. We just used it here as an illustrative example. But in the meantime, I actually believe, I mean, whenever we perform well in our job, we are somehow happy. It is perhaps not what we would love to see. We would more love to see that happy people perform better, and then as HR specialists or whatever, think about what can we do to make our people happy. But I actually believe it's more the other way around, and the effect, I would not say it's not there, but it's tiny, probably.
Any other questions here from the audience? So in the interim, while we're waiting here, I'm gonna post this question once more as you're developing this from what I gather, how you responded to some of the questions. You're working on this, how to cope with parsimony versus complexity in what to include in continuous time analysis versus not to include. So any thoughts on that, on the how parsimonious versus complex this continuous time meta-analysis can and should be?
So the only thing, I mean, it is just an add-on to this new method called continuous time modeling. And the only thing that is added by continuous time model to standard structural equation modeling is just the information about time lapse. And continuous time modeling in general is fantastic because until 5 years ago, almost all longitudinal studies were designed such that the time lag was always identical was invariant across all participants. It was usually pretty long, let's say, and the common study was a two-wave study with a half a year or 1 year time lag in many, many areas. Now this changes a bit. So time intervals in continuous time modeling may vary across participants. They may vary within participants using repeated, using studies with more than 2 waves of measurement. But the only information that is actually added to the models is time length. And then obviously comes the other question of the content. What do you add as further explanatory variables, further predictors? And I mean, this certainly varies from domain to domain. The problem for meta-analysis usually is that the variation in the variables that we use as control and further predictors is really, really huge across primary studies, that you almost never have a chance to do a meta-analysis with all these additional variables. So the perhaps most parsimonious model is actually 2 variables measured at 2 occasions. Yeah. What you could add, I mean, if you have 3 waves, you could add a lot of complexity with this within and between stuff Trevis is going to talk about, because then you can, for example, extract variation that is due to different contextual circumstances in the primary studies without having measured them. So this adds pretty much complexity, and there's a paper published in Organizational Research Methods 2 weeks ago by a large group of authors. Lead author is Zifur. I do not know whether I pronounce him correctly. It's Zifur, Allison, Hamakar. A lot of people go to the ORM research page, and they strongly suggest that some sort of complexity, for example, in terms of between and within variants, should be added. This is also possible with CODIMA, but you need primary studies with more than 2 waves. Yeah.
Oh, great. Thank you very much, Christian, also for offering this really nice segue into our next presentation by Trevis Certo. So please, everybody, use the Zoom group chat function here to shout out to Christian Dormann for what I found to be an exceptionally informative presentation. And having said this, I would like to hand over to Trevis Certo, who will indeed now expand more on between versus within unit effects in longitudinal data analysis. Trevis, the floor is all yours. Thank you.
Okay, great. Thanks, Thomas, and thanks, Christian, for so many references to this presentation. Let's see if I can get this to, you cannot start screen share. Let me see if I can get this to work here. I'm sorry. Christian, I think I need you to stop sharing the screen in order to start sharing mine.
All right, go ahead and try again real quick.
Okay, I'm sorry. Is that, hopefully that's working and everyone can see my slides at this point.
Yes.
So today I'm going to give a brief talk on within versus between effects. And in strategy, we look at this typically in terms of within and between firm effects, but you could certainly use the same techniques to look at individuals and teams in any sort of unit. I have a reference to a paper below. This is largely this presentation is largely based on this paper that we published in 2017. And I should just say that it's always a pleasure to talk to both micro and macro scholars, and it's always also interesting because some of these things, some of these concepts that we think are brand new in strategy, our micro colleagues have been talking about these for a very long time. And so, although we've seen a lot of papers on within and between effects in psychology journals and JP and things like that, but in strategy we don't talk about this as much. And so I apologize in advance if any of this is just too basic, but hopefully we can cover something for each and every one. So let me provide a brief overview. The first thing that I want to do is talk about introduce panel data and talk about the theoretical issues involved with looking at panel data or longitudinal data. The two terms are used synonymously. And then I want to talk about the most popular ways that are techniques that scholars have used in strategy to examine panel data. And then finally, I want to introduce what's called the hybrid method, which is a compromise between a couple of the more popular techniques used to analyze longitudinal data. So to begin, I want to just show a quick snapshot of a Stata data editor here. And you can see this is a data set that we pulled from CompuStat, I believe. And if you can see, there's right in the middle there is a column, and those are company names. Okay, and you can see many variables over there to the side. And what I want to demonstrate here is that if you look at any of these variables, you can see that there's variation, of course. But the point here that I want everyone to see is that we have within firm variance, and there's also between firm variance. And so if you look at that column that is labeled AT, you can see that the numbers are in the thousands for some firms, but they're down. For other firms, it's 6 or 7 or something like that. So what this shows is there are between firm differences, and there's between firm variation, I should say, and also within firm variation. So the panel data then allow us to look at two different types of static relationships. And I'm just going to focus on static relationships today, but there are also dynamic relationships, right? As you think about how one variable influences another over time, and maybe feedback loops and things like that. But we're going to focus on static relationships, and we can think about relationships within units, or we can think about relationships between units. And sometimes people don't really stop to think about the potential differences here. There's a great paper in the Annual Review of Psychology that really talks about the differences between within and between person effects. And I highly recommend this article because I learned a lot when I thought about it. But there's a great quote that I have here, that only longitudinal data allow for the proper separation of between person and within person effects. And this is, as they point out, it's critically important as we think about individuals, but also teams and firms as well. So I want to show some hypotheses that show the differences here. And really, I think in strategy, at least, if you look at the literature, what we see is that a lot of hypotheses look like the first one, which I label the original hypothesis, and that is R&D intensity is positively associated with firm performance. Now, we've seen a lot of hypotheses that look something like this. But it's important to know that when you have panel data, there are really two different relationships that are involved when it comes to R&D and firm performance in this example. And so I've included what I call the between hypothesis. And so if you look at this wording, firms with higher levels of R&D intensity will be associated with higher levels of firm performance as compared to firms with lower levels of R&D intensity. So that's that's one way to think about this. And in my experience, I think most people think like this when they form hypotheses and they test or they use longitudinal data to test these hypotheses. But there's also another alternative interpretation of this hypothesis if we think about within firm variation. And so I've proposed a third hypothesis here. Within firms over time, firm performance will increase following higher as opposed to lower levels of R&D intensity. So I know that the difference is subtle, but in the between hypothesis, this is talking about, well, firm A will outperform firm B if firm A has higher levels of R&D intensity. Whereas in the third hypothesis, it's, well, if firm A increases its R&D intensity, firm A will see differences in firm performance or improved firm performance. And so I know this is a very subtle distinction because most of the time we're thinking both of those operate simultaneously, right? That the relationship is the same between firm and within firm. But it doesn't have to be that way. And that's what we're trying to highlight with this paper. So there's really a basic equation that scholars use in strategy anyway, to examine this idea of between versus within firm effects. And this equation looks like a regular regression equation. There's just a mu term that's inserted, the mu I. And that accounts for these firm level differences in the dependent variable over time. And so you can see that the subscripts, I apologize, the subscripts here are IT for Y, IT for X, and IT for E. But for mu, the subscript is I. Okay, so that denotes kind of a stable difference between firms over time in the dependent variable. And so there are really two primary ways to analyze the data. Well, there are many ways to analyze the data, but I guess the two most popular ways in strategy have been a random effects model and a fixed effects model. And so a fixed effects model actually is somewhat confusing to those of you perhaps in psychology because the word fixed means something different. In this context, the word fixed is talking about a least squared dummy variable model. And basically although it's not exactly this, it's basically we're going to put a dummy variable in for each variable, for each firm, I'm sorry. And that will account for these differences, these between firm differences over time. Now, the random effects is more of just a mixed effects model, mixed model. And so it's basically a multi-level model, but it's using longitudinal data instead of data grouped within organizations or teams or something like that. And so really what we think about when we think about fixed effects versus random effects is the fixed effects model is, because it has dummy variables, it's a within firm model. So it's only looking at within firm variance. And a random effects model or a mixed model is looking at within and between firm variation. So for those of you who have seen strategy studies, what we typically do is run a fixed effects, we run random effects, and then we run a Hausman test to see which one we should use. And this Hausman test essentially tests whether or not the coefficients are different between these two models. And if they are significantly different from a statistical point of view, people will use the fixed effects model, because what people assume is that the between firm variation is contaminated in some sense, and so they rely mostly on they'll rely on the within variation as well. Now, I want to dive into the alternative, but to do that, I need to talk very briefly about between versus within firm variation. And there's a statistical tool known as an ICC. And for micro people, you're probably like, wow, that's not very impressive. I learned that 10 years ago. But for strategy scholars, we really have not thought about this all that much. The ICC allows us to understand how much of the variation or variables is due to within versus firm effects. And so here's the equation. You can look at that later. But the idea here is that when there's a high degree, when the ICC is high, there's a high degree of between firm variance. And when the ICC is low, there's not much, and it's mostly within firm variance. And when it's right in the middle, it's equal variance between the two. Now, what we did in this paper, and I could spend a whole nother session talking about the trials and tribulations of this paper and how many times it was rejected. And this is not actually in the paper, but it was in a former version of the paper where we actually calculated the ICCs of many variables that we typically use in strategy research. And we did it by the S&P 500, the mid cap 400, the small cap 600, and the total S&P 1500. And so as you look at these variables, you can see that the ICCs are very high. And those of you with experience doing this with micro research, you'll know these are really high, right? Look at the first variable, total assets, 0.86, right? So that means 86% of the variation in total assets in this data set is due to between firm effects. That means there's some really big firms and some really small firms. Now, you can look at these slides, and I'm happy to send them to anyone who wants them afterwards. But this has really important implications, right? Because this is basically saying for some of these variables, almost all of the variation is between firm. And what that means is that fixed effects models, which utilize only within firm variance, are not going to be very effective. There's just not a lot of variance there. And so Allison, who's a sociologist, developed what he called the hybrid method. And it's very simple, but it's the basic idea is that we can have the benefits of both the fixed effects and the random effects models. And what I mean by that is you basically create you split each variable in your model into two, a group mean and a group mean centered model. And so that group mean will help you understand the difference between a between firm effect, understand the between firm effect, and the group mean centered will give the within firm effect. And so we do this with a random effects model in the context, and I should have said that, so I apologize. But so using a random effects model and a mean centering and a group mean for each variable. And that group mean centered variable will give you the exact same coefficients as the fixed effects model. So what this does is it takes a fixed effects model, which has its own set of disadvantages, and it adds some information. And so we can now not only get that within firm effect, but we can also get between firm effects as well. There are Stata packages that allow you to do this very easily. So I adapted just a short, adapted this example from Crane and Bauer. So the beta for the group mean would capture the relation between average levels of R&D and average levels of performance while pooling over companies. The mean centered would capture the mean relation between a company's given time-specific deviation and the company's time-specific performance. So two different relationships. They could be the same, they might not be the same. But to us, this represents, okay, this is twice as many relationships that we can examine. And if they're the same, great. But if they're different, that opens up all sorts of new possibilities for theorizing. So what are the overall advantages? I've kind of gone over them, but they allow you to look at two different types, simply stated. But they also allow for a modified Hausman test. So you can actually run a Hausman test with these sorts of models as well. So closing thoughts, and I'm running out of time. It's kind of hard to believe, but panel data are almost assumed these days in strategy research, at least. And so long gone are the days of let's just send out a quick survey and we're good. We need to understand how to use and analyze panel data. And the second closing thought is that this is a theoretical as well as an empirical issue, and so there could be different effects, and I can get into that in the Q&A, examples of that. And finally, in order to do this, the hybrid method provides a compromise to look at both these effects. So with that, I'll open up any questions, and I just have this big fear that this has not been working the whole time, and I've been talking to myself, so hopefully that's not the truth.
Thank you very much, Trevis. And we are again waiting here for questions to come in from using the group chat function. And that is first one is right here. Any thoughts on dynamic models here, Trevis?
So thoughts on dynamic models. Well, these are becoming more and more popular. I almost toyed around with presenting those instead, but I did not. Dynamic models they use a form of GMM to find the results. I think these are critically important to understand going forward, but at the same time, my experience with them is that they are very unstable. I mean, you use some different instruments and you include different variables, all of a sudden the models completely change. So you have to be, I think, very careful of that. But there are some really good papers and books out there on dynamic panel models.
See any more questions?
Well, while we wait for questions, I just want to, I have one more example real quickly that was in the Cran and Bauer paper that talk about these between and within effects. And they talked about, and this example's always stuck with me, although I always have trouble repeating it, the difference or the relationship between body mass and longevity among mammals. And so I know that sounds strange, but the relationship is generally positive in that whales last longer or live longer lives than mice, as an example, right? But at the same time, if you look within species, right, that relationship is the opposite. So fatter mice don't live as long as skinnier mice, right? And so that has always kind of intrigued me. And if we can find examples of that in strategy research or management research where you find one relationship at one level and in the opposite at a different level, I think that could be really, really exciting. The problem, of course, is that it's hard to think of those examples.
All right, we got some more questions here coming. First, what are your thoughts on addressing endogeneity in fixed effects panel models?
So what are my thoughts? Okay, so I could speak for months on endogeneity, as some of you probably know already, but I think my primary thought is that with fixed effects models versus random effects models, people tend to think that, okay, if I get a significant Hausman test, that I have to I'll use the fixed effects models and that's clean. And the fact is, there are really two different types of endogeneity. There's level 1 endogeneity and there's level 2 endogeneity. And what the Hausman test is really testing is level 2 endogeneity. So is there endogeneity at the higher level? But you could still have endogeneity at the lower level. So a fixed effects model, you could still have endogeneity, right? I mean, you could still have omitted variable bias and things like that. And so I don't think you'll ever be able to get around it. I mean, there are different techniques. You can look at exogenous shocks and you can look at diff and diff models. You can look at discontinuous regression models and things like that. But you'll never really, I don't think, ever be free from endogeneity.
Mm-hmm. We have a next question here. I read it. If we are really interested in within subject change, how might group mean centering affect our ability to detect change?
I'm not sure I follow the question.
Yes, I'm trying to make sense of it as well here. So the question is on within subject change and how group mean centering may affect our ability to detect change. If you, and it's there in the group's Zoom chat function if you like to read it for yourself.
Yeah, I don't see that question. So, I mean, at a very broad level, looking at within firm change, within a firm is a group mean centered variable, right? And so, I mean, they kind of go hand in hand if I understand the question. But there are also, other sorts of techniques like the diff and diff models that allow you to look at that. There are also models like growth models can be helpful in that regard too, to look at within person change.
Yeah, actually, I'm sorry, I just realized that this question was sent to me private. I missed that.
Oh, okay.
I'll post this here now for everyone. so that everybody can see it also still. So yes, when you are sending in questions, please try to send the question to everyone in the Zoom group chat function so that everybody can see them.
Yeah, again, I mean, I think you actually have to have group mean centering in a way, I mean, to do this, because that is within person change, right? You're looking at within person change over time. So I don't think it, if I understand the question correctly, I don't think it harms your ability to do that. If you are really interested in within subject change, I would suggest Singer and Willett. It's a 2003 book that uses growth models and talks about the issues involved with examining change over time, and that change is really a difference score. And so if you're looking at within person change, you can look at this as, yeah, your DV is whatever you're looking at in terms of changing in time is your independent variable, and you can look at how, you know, factors that influence the slope, whether it goes up and down and things like that. So there are all sorts of different ways.
Okay. Another question here, how would you integrate interaction effects in the hybrid model?
Yeah, good question. You know, this is, we've had students go around and around with this, and recently even in terms of dissertations. I would advise, there's a shrunk paper in the Stata journal that looks at interactions. Using the hybrid method, Shrunk is the individual who I think developed the package for Stata, the Ado package, which is easy to install. But there are all sorts of different opinions about which exactly which to use, and to be quite honest, I'm not entirely sure the answer to that. I just know that all of a sudden now assume that you have two variables that you want to interact, but now you've split each variable into two, and so now you have four variables. And so now it becomes difficult, and I don't know the exact answer in terms of which ones do you multiply to get the right effect, so to speak.
Okay. Well, while we were waiting here for any other questions to come in, Trevis, I would like to ask perhaps briefly in terms of a link between Christian's presentation and now yours. Do you think that as we see more panel data studies, as you alluded to in your presentation, in strategic management research, there will be also the need for the COTIMA, the meta-analysis on time effect? So how would you see that?
Yeah, you know, I've published a few metas. I'm not an expert in that by any stretch. You know, the one criticism that we've received, and you know, Christian might have more thoughts on this, is that, you know, metas, I think, are really important when you have a topic and you have all sorts of different samples, and you can combine all those samples together, right? Obviously, that's the point of metas. But for strategy, we're typically using the same databases over and over. And so if, you know, even though your paper may have been last year, mine's this year, we both use CompuStat. And so we're looking at the relationship between R&D and ROA. That presents problems just in general in terms of metas. So I don't know if that applies to, you know, Christian's technique or not. I'm imagining that it does, but I don't know that for sure.
Okay, very interesting. We have one more question here. What are some restrictions when choosing the firms to compare between firms?
Well, I don't, you know, there are some matching techniques that you could use, but I think what I've been talking about today is these are different techniques for just downloading a sample of firms, regardless of any sorts of matches or restrictions or anything like that. So you could have dramatically bigger firms also in the sample with dramatically smaller firms. So it doesn't really require any sort of restrictions, these two techniques anyway. But if you were getting into matching and using, you know, diff and diff, then restrictions become more important.
Okay. So there are no other questions here. So perhaps to use the last few minutes, we can open the floor if there are any remaining questions for any of the panelists. And of course, please also use the group chat function here again to shout out to Trevis and thank him for a very informative presentation here. So we have a few more minutes. Any remaining questions for any of the three panelists, we can still take it on. right. That's okay. We have a comment more so than a question, referring to a series of 2 papers published in ORM on dynamic panel models. Maybe interesting to some of you. And well, it looks like there are at this point no questions for the panelists. So what I would like to do here is close this session by one more time thanking all 3 of our wonderful panelists, Philipp Tuertscher, Christian Dormann, and Trevis Certo, for 3 great presentations. And I certainly can say that I walk away from this learning something new about several different approaches here to longitudinal data analysis, and I hope you had the same experience. And as we're closing, also I would like to thank once more our partners at Karma, Larry Williams and Andrew Hanna, who was working behind the scenes here to make sure that all the technical aspects worked well. And as usually also would like to acknowledge and thank the track chairs of this consortium, Joanna Campbell from the University of Cincinnati, Jose Cortina from Virginia Commonwealth University, and Sanjay Jain from North Carolina State University, California State University of Northridge, I apologize, and our wonderful R&D student representatives, Nitya Chawla, Elizabeth Clayton, Yifan Song, and Ki Sam, for all the help to making this possible. So again here, thank you very much, you 3, for a great session. And I would not be surprised if you would be contacted by some of our panelists here, some of our participants, with some follow-up questions to your presentations.
Okay, thank you. And I also just posted a link, a Dropbox link for the chapter. I received a few requests, so you can download it right from the chat there.